everyone, welcome back to my channel SJR Comtech. Already I uploaded the videos related to the number system conversion as well as binary arithmetic and BCD arithmetic. Today we are going to start with the new topic, that is logic gates. So first of all, let me tell you what is logic gate. Gate is nothing but the logical circuit which is used as a basic building block to design any digital circuit. So whenever we are going to design any digital circuit, the gates are must. So today we are going to see the symbols of the gates, but actually those are only for our understanding purpose. Internally those gates are nothing but the circuit only, which may consist of the resistor, transistor, diode and other things also. So there are three categories of the logic gates. First one is the basic gates. Under the basic gate, three examples are there. First one is NOT gate, then AND gate, and third one is OR gate. Second one is universal gates. There are two universal gates. One is NAND gate and another one is the NOR gate. So actually why these gates are called as the universal gate, I will tell you later. So please do watch video till the end. And then now next one is third category. There is no any special name for it. You can call them as other gates or special gates. There are two examples of those gates. One is exclusive OR and another one is the exclusive NOR. So you can call this exclusive OR as X dash OR, or here you can write EX dash OR also. And for the exclusive NOR we can write as X dash NOR, or we can write EX dash NOR also. So in today's video we are going to see these things. First one is operation of each gate, for what purpose that particular gate is used. Next one is what is the symbol of the gate. Then next one is the truth table. So what is the truth table of any gate? Truth table is nothing but the combination of all the inputs and the output for all those input combinations. And the last one is we are going to see the Boolean expression for each gate. So this Boolean expression is nothing but the expression which help us to find out output of the gate for the given inputs. So now let me start with the first category of the logic gate, that is basic gates, in which three gates are there: NOT, AND, OR. Now we will see the first basic gate, that is NOT. So actually what is use of the NOT gate? First we are going to see what is operation that particular gate is going to perform. So NOT gate is used to take the complement of the input, or it is used for the inversion process also. So here I will write inversion. So this is the operation that is performed by the NOT gate. We can call it as the complementing also. Complementing the input. So this is the operation which is performed by the NOT gate. Now the next one is the symbol of NOT gate. The symbol of NOT gate is triangle like this, and then here bubble. Now what is left here actually? Here we have to show the input lines as well as output line. So NOT is a gate which takes single input. So here I will show single input line. Suppose that input is called as A. I will give name A to the input, and here I will get the single output. I will call it as Y. So output is represented by using the Y, and here we can give any name to the input. Single input is there, I have given name it as A. So this is about the symbol of the NOT gate. Now next we are going to see what is the Boolean expression for the NOT gate. So next here I will write the Boolean expression Y equal to, it is going to invert the input or it is going to complement the input. What does it mean? Input A is there, take its complement. So to represent the complement I have to write bar, that is simple slipping line over the input letter A. So Y equal to A bar, this is the Boolean expression of the NOT gate. What is use of Boolean expression? Boolean expression is used to find out the output of any gate. Now the next thing about the NOT gate is truth table. Then I will write here output. Okay. So how many inputs are there? Single input, which is represented by using A. So below input I will write A. Output. Output is represented by using Y. And what is Boolean expression for the output? That is Y equal to A bar. Okay. Now next I have to find out how many input combinations will be there for particular gate. Okay. So for that I must know how many input lines are there. How many inputs are there for the gate. So here how many inputs are there? Only single input there. So the value of n is equal to 1. Then I have to use this formula. 2 raised to n is equal to number of inputs. Number of inputs equal to 2 raised to n. So what is value of n here? That is 1. So put the value of n. 2 raised to 1. 2 raised to 1 is equal to 2. So the number of inputs for the NOT gate equal to 2. So what are those two possibilities of the input? Here you can see single variable is there. So its value can be either 0 or 1. Why? Because we know in binary number system only two symbols are used, that is 0 and 1. So there are only two possibilities. A can be either 0 or 1. So here I will write two possibilities. A can be either 0 or 1. Now what I have to do? I have to find out the output for each input combination. Now see here, the first input is what? 0. And this NOT gate is used to invert the input or to complement the input. What do you mean by complementing the input? Suppose the value of A is equal to 0, then output will be 1. That means it will change 0 to 1. If the input of the NOT gate is 1, then it will change it to the 0. That means whenever the input is 0 of the NOT gate, output will be 1. If the input of NOT gate is 1, A is equal to 1, then output will be 0. So 0 to 1 and 1 to 0. So this is how NOT gate works. Now here you can see in this symbol of the NOT gate, one small bubble is there. So this actually small bubble indicates the NOT operation, that is inversion operation. So whenever we want to take the complement of input, we have to use this NOT gate. So this is very small and simple symbol of the NOT gate. The Boolean expression for the NOT gate is Y equal to A bar. Suppose if I represent the input line as B, then the expression will change like this, Y equal to B bar, or simply you can call it as B complement also. Next one is truth table. First find out the number of input combination by using this formula 2 raised to n, where n is nothing but the number of inputs. Now remember, NOT gate is the only gate which takes single input. It will never take more than single input. So always the number of combinations will be 2 only. First value will be 0, another will be 1. If the provided input is 0, then output will be 1. If the provided input is 1, then output will be 0. So this is about the NOT gate. Now let me start with the second basic gate, that is AND gate. The AND gate actually used for taking the logical multiplication. So whenever we want to take the multiplication of inputs, that time we have to use the AND gate. So this is the operation that is performed by using the AND gate. Second is symbol. Symbol of AND gate, very simple. Draw the standing line, two sleeping line and curve like this. This is the symbol of the AND gate. Now what is left here actually? Here we have to show the input lines, and to the right side we have to show the output line. Remember, each and every gate gives a single output. Okay. It may take one or more than input, but always it gives the single output only. Now I am going to consider the two input AND gate. That's why two input lines I have to show here. Suppose first input line, its name is A. Now second input line, suppose it is represented by using the B. Now third thing we have to see, that is Boolean expression. So I will write y equal to, first see what is purpose of this gate. It is used for logical multiplication. So it is used to take the multiplication of the inputs. So what are the inputs? A and B. So y equal to A, B. As it is used for multiplication, I will put dot here. So the Boolean expression for the AND gate is equal to y equal to AB. Also I can write it as only AB also. So I can remove this dot. Nothing is there in between A and B. It represents the multiplication operation only. Now the next thing is that we are going to see what is truth table. But before going to see the truth table, we should know how many input combinations will be there. Okay. So to find out the input combinations, I will write a number of inputs equal to 2 raised to n, where this n is nothing but number of inputs. How many number of inputs are there? 2. So put the value of n as 2. So 2 raised to 2 equal to 4. So how many input combinations are there? 4. So now write the truth table. First I will write input. Truth table contains input as well as output. Input, how many inputs? 2 inputs. So represent A as well as B. Output is represented by using the variable y. And now write the expression, that is Boolean expression, y equal to AB. Now next thing is that I have to write all the input combinations for the AND gate. Okay. So 2 inputs are there. So 4 input combinations. First one is 0, 0. Next one is 0, 1. Then next 1, 0. And then 1, 1. Okay. You can see the first input combination where the value of A is equal to 0 and the value of B is equal to 0. So put the value of A as well as B in the Boolean expression to find out the output of the AND gate. So here I will write y equal to AB, A equal to 0, B equal to 0. So 0 into 0 equal to result will be 0. So for input A and B 0, 0, output is 0. Now in the same way we can continue for the remaining input combinations also. See the second thing where A is equal to 0, B equal to 1. So the value of A is 0 and B equal to 1. So 0 into 1 again equal to 0. Why? Because in multiplication, if at least one of the input is 0, then output is going to 0 only. Next, see the value of A is, this is done, this is also done. Now see the third row where the input A is equal to 1 and input B is equal to 0. So put the value of A and B here in the expression, 1, 0. So 1 into 0, result is 0. Now see the last row, A is equal to 1, B is equal to 1. So put the value of A is 1, B is 1. So y equal to A, B, 1 into 1, result is 1. That is output is 1. So now here you can see this truth table and we can conclude whenever all the input combinations are 1, that time only we are going to get the output as 1. Otherwise the output is 0. Suppose AND gate is taking 10 inputs. In that case, if 9 inputs are 1 but single input is 0, then also output is 0. That means if any single input is also 0, output is 0. And if all the inputs are 1, then and then only the output of the AND gate is 1. So now next we will see the OR gate. Addition. So this is the third basic gate, that is OR gate. Its operation is used for logical addition. Its symbol curve like this, and then this is the symbol of the OR gate. This is output line. Always it is represented by using the Y. As I am going to consider two input OR gate, two input lines will be there. First one is, suppose it is represented by using A, second represented by using B. You can choose any variable whichever you want for the input as well as the output also. Now next thing is that the output the Boolean expression for the OR gate, that is Y equal to, as it is used for the logical addition of the input combinations, I can write the Boolean expression as A plus B. Actually we call it as A or B. Why it is called as A or B, you will come to know when I will write the truth table. So before going to see the truth table, let me tell you how many input combinations will be there. Again, the number of inputs equal to 2 raised to n, where n is nothing but number of inputs. Here number of inputs equal to 2. So put the value of n is 2. 2 raised to 2 equal to 4. So 4 input combinations. Now here I will write inputs. Here I will write output. Two inputs are there, A and B. Single output, always single output is there. Here the Boolean expression for the OR gate is A or B. That OR is represented by using the plus, and 4 input combinations will be there. Easily you can remember those all 4 input combination like this. For this first input combination from the right side, write 0 1 0 1, single 0 single 1 like this, and for the next write 0 0 1 1. So this is how very simple to write all the input combinations. Now see how to find out the output by using this Boolean expression. Here the value of A is 0, value of B is 0. So put the value of A and B in the Boolean expression. So 0 or 0, the result is 0. Second, A is equal to 0, B equal to 1. So 0 or 1, output is 1. Next, 1, A equal to 1, B equal to 0. So 1 or 0, output is 1. Next, A is equal to 1, B is equal to 1, 1 or 1, output is 1. Now here you can see in this truth table, actually this is not exactly opposite to the AND gate, but in AND gate we were getting the output as 1 only if all the inputs are 1. And now here we can conclude that we are getting the output as 0 only when all the inputs are 0. So if single input is also 1, then output is 1. So when we are going to get the output as 0, if all the input combinations are 0. So just try to remember the difference between AND gate and OR gate. AND gate used for the multiplication. If all the inputs are 1, then only output of the AND gate is 1. And in OR gate, if all the inputs are 0, then only the output is 0. Let's start with the universal gates. There are two universal gates. One is NAND gate and one is the NOR gate. So actually why this special name, that is universal gates, is given to these particular gates? Because we have to perform logical addition operation, then logical multiplication operation, as well as inversion operation whenever we are going to design any digital circuit. But suppose sometimes if we don't have the AND gate, OR gate or NOT gate, so in that case if we have only NAND gate, then also we can design any digital circuit in the world by using the single gate, that is NAND. And the same thing happens with the NOR gate also. Suppose we are going to have the IC of only NOR gate, then also we can design any circuit. Then how we can design? We have to convert the expression in such a way that we can use those particular universal gates. And as it is possible to realize any expression by using these two gates, these gates are called as the universal gates. So first let me start with the first universal gate, that is NAND gate. Now you can see this NAND is the combination of the NOT and AND. So this N stands for the NOT and this is the AND gate. So NOT AND. So this actually gate performs the exactly opposite operation of that AND gate. So what is the symbol of the NAND gate? Symbol of the NAND gate. First we have to draw the symbol of the AND. I am going to consider two input gate. So two input lines. First input A, second input B. Now see, it will give you only one output. Now this output is nothing but the input of the NOT gate. Okay. So this AB, A first input, B second input. So output of this NAND gate will be AB, which is acting as an input of this NOT gate. So the use of NOT gate is to take the complement of its output, complement of its input. So what is input for this NOT gate? That input is nothing but the AB. So it will take the complement of its input AB. So this is the final Boolean expression for the NAND gate. But here two symbols we have to use. So there is one shortcut, that is we will draw this AND gate symbol, write the input as A and B, and now replace this NOT gate by using this small bubble at the end of this AND gate. So just looking at the small bubble after the AND gate, we must come to know, yes, this bubble is used for the inversion purpose. So this is NOT and that's why this gate is the NAND gate. And its Boolean expression is y equal to AB bar. Y equal to AB bar. Now next we will see the number of inputs. Again the same thing. Number of inputs equal to 2 raised to n. N is nothing but the number of total number of input combinations is equal to 2 raised to n. So the number of inputs is equal to 2. So put the value of n is 2. 2 raised to 2 equal to 4. Now write the truth table. Inputs. 2 inputs A, B. Now first I will write the input combinations. Same thing. 4 inputs are there. Not 4 inputs. 4 input combinations are there. How to write? 0, 1, 0, 1, 0, 0, 1, 1. So this is how you can write the 4 input combinations. Now to find out the output AB complement, first I need to find the AB. So here I will write one column. I will call it as AB. First I will try to find out AB. So this AB is output expression or Boolean expression of AND gate. So value of A is 0, value of B is 0. So 0 into 0, 0. Then next one is 0 into 1, 0. 1 into 0, 0. 1 into 1, 1. So output of the AND gate is 1 only if all the inputs are 1. Now I want to find out the AB complement. So here I will write output y equal to AB complement. How to find out the complement? Complement is nothing but use of the NOT gate. NOT gate take the complement of its input. That means if input is 0, output is 1. If input is 1, output is 0. So these are the values of the AB. I want to find out AB complement. First value of AB is 0. Its complement 1. Next value of AB is again 0. Its complement 1. Next value is 0. Again its complement is 1. Here the value of AB is equal to 1. So the AB complement will be 0. Now you can see actually this is the column of output of AND gate, and this is the column of output of NAND gate. These two columns, or we can call output of the AND gate and output of the NAND gate, these are exactly opposite to each other. 000, then here for the NAND gate 111 is there. Here the output of AND gate is 1, here the output of NAND gate is 0. So if you know the AND gate, easily you can write the truth table for the NAND gate also. Now we'll start with the second universal gate, that is NOR gate. Second universal gate, that is NOR gate. Here also the name itself indicates this N is nothing but the NOT and this is the OR. So this is going to perform the operation which is exactly opposite to the OR gate. So here I will write NOT OR. The symbol of this is, first I have to draw the symbol of OR gate. Two input lines. Then NOT gate. And this is the final output. So here you can see the output of the OR gate is nothing but the input of this NOT gate. So the output of OR gate is A plus B. This is nothing but the input of the NOT gate. So Y equal to A plus B and its complement, because NOT gate is used to take the complement of its input, and that complement is represented by using the bar over the input. Now next one is, every time whenever we are going to represent the symbol of the NOR gate, we will not represent like this, because two gates we have to use here. So what we will do, draw the symbol of the OR gate like this and replace this NOT gate by using small bubble at the end of the output, and now represent it by Y. Input is A, second input is B. This small bubble represents the inversion or complement or NOT operation. So the output of this OR gate is equal to A plus B, and this symbol bubble is going to take its complement, so A plus B whole bar. Now next we are going to write the truth table for the NOR gate. Truth table, no need to write truth table here, directly I will write the inputs. Two inputs are there. So how many combinations will be there? Number of inputs equal to 2. So the value of n is 2. 2 raised to 2 equal to 4. One, 2, 3 and 4. Which 4 combinations? 0, 0, 0, 1, 1, 0 and 1, 1. Now what I have to find out? I have to find out A plus B whole bar, but just for some time try to hide this complement. So first what I have to do? I have to find out A or B, that is A plus B. So I try to find out A plus B here. The value of A is 0, value of B is 0, 0 or 0, 0. First input is 0, second input is 1. 0 or 1, 1. 1 or 0, 1. 1 or 1, 1. Now next is what? A plus B whole bar. So here I will write output Y equal to A plus B whole bar. Now you can see the A plus B values are here. Okay, I got the values of the A plus B. By using these values, I will find out the A plus B whole bar. The value of A plus B is 0. So when I take its complement, it will become 1. Next value is 1. So here value will become 0. Again the third value is 1. So 0. See here the next value is 1. So output will be 0. Now you can see these two columns. Actually, this is nothing but the output of the OR gate, and this is nothing but the output of the NOR gate. So these two columns are exactly opposite to each other. So 0 1 1 1, this is the output of the OR gate, and 1 0 0 this is the output of the NOR gate. If we write all the input combinations in the same sequence. So this is all about the NOR gate, that is universal gate. Next we will start with the XOR gate. So suppose the first special gate, or we can call it as the other gates also. There is no any specific name for this. Like exclusive, or we can write it as EX dash OR. Sometimes we write it as X dash OR also. Okay. So the symbol for this is, again I am going to consider it for the two inputs only. So first draw the symbol of the OR gate, and then just behind it draw one more curve. So these two curves represent, this is either exclusive or exclusive NOR. So this is symbol of the exclusive OR gate. Suppose the first input is A, second one is B, output is Y. To represent this exclusive OR, the plus sign is used inside the circle. So plus inside circle, it indicates the exclusive OR, that is XOR gate of the input combinations A and B. So actually this expression we can write it as A bar B plus A B bar. So this is the actual Boolean expression for the exclusive OR gate. But instead of writing this expression every time, this is the shortcut way to write the Boolean expression of the XOR gate. So now next we will see what is truth table of the XOR gate. So in truth table, first I have to write the inputs. How many inputs are there? Two inputs are there. So write A and B. So how many input combinations will be? 4. One, 2, 3, 4. The next, what I have to find out? See this expression, I need to find out the A complement as well as B complement also. So here I will write A complement, then I need to find B complement also. Now next, after this I need to find A complement B. Then next I need to find the AB complement also. And at last I can find the output, that is Y equal to A bar B plus AB bar. So 4 input combinations, 0 1 0 1 0 0 0 double 0 double 1. So these are the 4 input combinations. The value of A, double 0 double 1, so A complement will be 0, it will become 1. Here A is equal to 0, so A bar will be 1. Here the value of A is 1, so here it will become 0. Value of A is 1, so it will become here 0. Now find out B bar. B is equal to 0, so B bar is 1. B equal to 1, so B bar equal to 0. B is equal to 0, so B bar will 1. Now next B is equal to 1, so B bar will become 0. Now I need to find out A complement B. That means I have to take the multiplication of value of A complement and B. So multiplication of these two columns, 1 into 0, 0, 1 into 1, 1, 0 into 0, 0, 1 into 0, 0. Now next I need to find out A B complement. So the column of A and see the column of B complement. So 0 into 1, 0, 0 into 0, 0, 1 into 1, 1, and here 1 into 0, 0. So now I got the A complement B as well as AB complement. Now I need to take OR logical addition of these two columns. So 0 or 0, 0, 1 or 0, 1, 0 or 1, 1, 0 or 0, 0. Now you can see whenever two input combinations are different, A and B, here A is 0, B is 1. Here A is 1 and B is 0. That means two inputs are 0. That time only I am getting the output as 1. But whenever two inputs are same, it could be either 0, 0 or 1, 1. But that time the outputs are 0. So this is how you can remember. So whenever actually you are going to write the truth table, no need to write the column of A complement, B complement, this A complement, B and AB complement. You can just remember whenever the inputs are same, that time the output of the exclusive gate is 0. If the inputs are different, then output of the exclusive OR is 1. So you can ignore or you can avoid writing these four columns. But suppose if the expression is given like this and you need to find out the output, final output, then you have to show all these things. And if in the case you don't know what is the output of the XOR gate, simply you can follow all the steps. So this is about the exclusive OR gate. Now next we will see the next special gate, that is exclusive NOR gate. Exclusive NOR, we can write it as EX dash NOR. Also we can write it as X dash NOR also. The symbol of the exclusive OR is same as exclusive OR. Only the difference is that as this NOR, this N indicates the NOT operation. So we have to draw very small bubble at the output side. Output is Y, inputs are A and B. And the output Boolean expression is A encircled B, encircled plus then B. Actually this is the expression of the XOR. Now NOT operation is there, so just complement over it. Same we can write it as A bar B plus A B bar and its complement. Okay. Now we will write the truth table for the exclusive NOR gate. Inputs. How many inputs are there? Two inputs are there, A and B. So 4 input combinations will be there. 1, 2, 3, 4, and those are 0, 1, 0, 1, 0, 0, 1, 1. After doing the practice, you can write directly 0, 0, 0, 1, 1, 0 and 1, 1 also. Now, whenever we are trying to find out the output, which things we must know? The value of A complement, value of B complement. Then we need to find out the A complement B as well as AB complement, then their addition and then the final complement. So I will write here A complement. Then I need to find out the A complement B. Next I need to find B complement. Then find out AB complement. Next their addition, A complement B plus AB complement, and finally we will find the output, that is Y equal to A complement B plus AB complement and whole complement. Now you see here the value of A is 0, so A bar is 1. Next 0, so A complement 1. A is equal to 1, so A complement 0. A is equal to 1, so A complement again 0. Now find out A complement B. So multiplication of these two columns, 1 into 0, 0, 1 into 1, 1, 0 into 0, 0, 1 into 0, 1. Sorry, 1 into 0, 0. B complement. the values of B 0 1 0 1. So B complement 0 to 1, 1 to 0, 0 to 1 and 1 to 0. Now take the multiplication of A and B complement. So column of A and column of B complement. 0 into 1, 0, 0 into 0, 0, 1 into 1, 1, 1 into 0, 0. Now I am having the A complement B as well as AB complement. Next I need to find out the addition, logical addition of these two. So 0 or 0, 0, 1 or 0, 1, 0 or 1, 1, 0 or 0, 0. Okay. Now what is left? I need to find out the complement of this whole expression. So 0, its complement 1. Complement of 1 is 0. The complement of 1 is 0. Here the complement of 0 is 1. So actually here I have shown you all these steps, each and every step, how to find out the A complement, B complement, then A complement B, AB complement. But actually whenever you are going to write the truth table, no need to write these steps from this column to this column. You can write the input possibilities and directly you can write the output column also. But if you don't remember the output column, then how to find out that? For that you have to follow these particular steps. So now you can observe that actually this is nothing but the output of the XOR gate. So output of the XOR gate is 1 only when two inputs are different. Okay. Here the two inputs are same. That's why output is 0. The output of, see these two columns, output of XOR gate and output of the XNOR gate is exactly opposite to each other. The output column of the XOR is 0 1 1 0 and for the XNOR it is 1 0 0 1. So for the XNOR gate the output is 1 only when the inputs are same for the two input XNOR gate. So this is about all the logic gates, basic gates, then universal gate and special gates. So my next video will be about the multiple input basic gates as well as universal gate as well as special gates. So please do watch these videos. I will provide the link of all these videos in the description box. If you like the video, click on like, and if you have not subscribed my channel, please subscribe it and don't forget to click on the bell icon also to get the notification of my next uploaded videos. And most important thing, share it with your friends so that they can also watch the videos and they can easily understand all these concepts.